So this is the NLP final project report for Team Coconut. So starting off with question generation, our outline is pre-processing and decomposition of a sentence into simple sentences, then binary question generation, WH question generation, and then finally ranking. So starting off with pre-processing and decomposition, the first step was parsing and annotating the actual sentences into tokens, so using NLTK and spacey. And then we sought to remove beginning clause. So for instance, sometimes in sentences, there's like a beginning clause that just has some unnecessary information, like before dinner he called his parents. We wanted the sentence to return he called his parents. So to do that, we used spacey's dependency parser, and we looked for commas and then checked the preceding clause if it didn't contain any important information like root, subject, or object, then we took it out. So then we split a longer sentence that had multiple full clauses into smaller sentences, and to do that we used Berkeley's neural parser, which is a constituency parser, and to do that we traveled through the parse tree that it generated, and we would split sentences if it was in the form noun phrase plus verb phrase. Then, for decomposition, we looked at relative clauses. So using spacey's dependency parser, we looked for the tag RELCL, and if we saw that tag, then we would split the sentence up into 2 to 3 smaller sentences depending on the who or the what or the where or the when word that was that started off the RELCL clause. Then for decomposition, we looked at apposition. So this was also through spacey's dependency parser that looked for the tag apos, and we used a recursive approach similar to the one of relative clauses in case there were multiple apposition phrases to then split the sentence up into several sentences. Then finally, for decomposition for conjunction, so the sentence he went to work, had some coffee, and bought a car would become he went to work, he had some coffee, he bought a cat, and to do that we used spacey's dependency parser to again look for the tag conj. Going into question generation with binary questions, we had 3 types. We had just verb questions, so Jonathan walked to the store became did Jonathan walk to the store. Sue has gone crazy would become has Sue gone crazy, which is containing an auxiliary, and Bethany is very smart, so just to be verbs would become is Bethany very smart, and to that we just mostly use spacey. To make our questions a little more complicated, we used WordNet to look for possible antonyms of adjectives found in binary questions to add some more complexity. For WH questions, we split it into 2 categories. So one, if the sentence contained an auxiliary, so Stacy is walking to Canada, would become where is Stacy walking to, or no auxiliary and just a verb, so Stacy walked to Canada would become where did Stacy walk to. And to do that, similar to binary questions, we used spacey's NER to look for those named entities, so Stacy or Canada, as well as spacey's dependency parser. So then finally, with ranking, our ranking criteria was 2 to 1 for binary questions to WH questions. With binary questions, we optimized for longer length questions, and WH questions, we optimized for the middle of the pack questions. We also prioritized sentences or questions that contained a named entity and that didn't contain a pronouns, because those could be very ambiguous. And also, we wanted to keep our lengths between 5 to 20 words. So then moving on into question answering. So our outline is we split this 2 parts into sentence identification and parsing. So starting off with sentence identification, we first wanted to, throughout the whole article, look for the sentences that would most likely contain our relevant answer. And to do that, we would essentially implement a ranker that would rank the questions based off its relevance and the amount of common words that it shared with the question. So in order to do that, we used the metric called TF-IDF. So we would calculate a TF-IDF score for each of the words in the sentence and then average it out to get the total score for that sentence. And then we would rank the sentences based off their averaged score. So because TF-IDF didn't handle sentences that used synonyms or antonyms, we also incorporated word embeddings, so we used glove, and this would basically weigh the TF-IDF scores. So using all of that, we would then return the highest ranked sentence as a possible answer to the question. So then with parsing, so once we identified the sentence, we would then want our model to generate the part of the sentence that would answer the question, and we would want the part that was generated to be fluent and human-like. So we used Stanford's core NLP server, the dependency parse tree, and the constituent parse tree to then identify the phrase of the sentence that was most notably, that would be the most relevant. So with WH questions like where is the Statue of Liberty, when was Caesar killed, who was the first person to land on the moon, which is Jack's favorite season, we would use named entity recognition, and based off the specific tag, so whether it be location, a date or time, or person or organization, we would incorporate the syntactic structure and dependency parse tree to then generate the most relevant phrase that would answer such a question. So, yep. Thank you for listening, and that was our project.